remember, like our friendly sysadmin showed up and told us, hey, you need to use like entropy. So you don't have enough entropy. So what we want is to run one instance of RNG per node. It doesn't mean that we will scale to 4, because if we scale to 4, maybe they will be all on the same node, or like they. So instead, we are going to use something called a daemon set. A daemon set is a construct exactly for that, like when you want to run one instance per node. So instead of a deployment, we need a daemon set. And here we have kind of good and bad news. Oh yeah, and there were some questions earlier, like what if I want to run stuff only on a subset of the cluster? I have a link here on the slides showing how you can run a daemon set only on some specific nodes. So a use case is when you have those fancy like hardware in some nodes and you need to run an agent to manage that hardware, you can put labels on these nodes, and then you can create a daemon set that says, run that container on all the nodes with that label. So bad and good news. Bad news, the CLI cannot create a daemon set. So it's like, what? How are we going to do then? Well, if we want to be more accurate, we don't have a specific subcommand to create a daemon set. Not yet, at least. So we can't do like kubectl daemon set whatever. But we can create anything as long as we have the YAML for it. So we could do like, we could create the YAML for the daemon set and then kubectl apply that YAML. How can I create the YAML for a daemon set? I have two options. I could try to read the docs. Or I could just try to like, you know, experiment a little bit, and if we're lucky, things will work. So a daemon set and a deployment should be pretty similar things. So I'm going to get the YAML for the RNG deployment. So and then we're going to tweak it. So kubectl get deployment RNG -o YAML, and I'm going to add a special flag --export, and that flag means it's not exactly give me YAML that I could use like to recreate the resource, but it will remove a bunch of information that is irrelevant, like the status of the deployment. When we create something, we don't care about the status. Yeah.
If this YAML is versioned, can I roll back to previous one?
Yeah, good question. Like, can I put this YAML in my Git repo? And absolutely you can, and even you probably should. And can I roll back to it? Yes. The whole point of that is that once your resources are created, if you apply, if the resource already exists, it will change the definition of the resource. So yes, you can absolutely have like this big YAML file to describe your application. You check out to another version, you apply, and if you're lucky, everything will go to that specific version. So I'm going to put that in rng.yaml. And then I'm going to look at that YAML file. And it says kind deployment, and then it says, yeah, labels and blah, 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 and blah, 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 and lots of things that honestly I quite don't understand. But it's okay, because I'm just going to experiment a little bit. So I'm just going to change the kind. It says it's the type of the thing. It says this is a deployment. I say, no, this is a daemon set. And that's it. It's like changing the type of an object in the programming language. I save, whoops. I save, I exit. Oh, it's still deployment. Yeah, good point. I screwed up here. So I change it to daemon set, and then a friendly coworker points out that I undid my change somehow. I change to daemon set, I save, I exit,
no.
and
Okay.
oh, yeah, WQ or X, but not anything else. kubectl apply -f rng-yaml. Yeah, and here I have like a bunch of errors, and then another coworker is like, I told you that it wouldn't work. What were you thinking? So it says error validating data, blah, 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 blah. So I'm kind of an impatient person, so I go to the end and it says, if you choose to ignore these errors, turn validation off with dash dash validate equal false. Why is everybody laughing? Daemon set RNG created. Ha ha. Okay, let's look at the errors that happened here and let's try to understand why it worked. It says unknown field replicas. So there is a schema and there is validation. And for a Daemon set, the number of replicas doesn't make sense. The number of replicas makes sense for a deployment, and by default it's 1. But for a Daemon set, I just want to have 1 pod per machine, and so replicas makes no sense at all. If I continue, there is something about like strategy, which is the strategy used to do rollouts, and again, this is specific to deployments. I have another like missing required field, current number scheduled, etc., etc. But all these fields are not strictly mandatory. They probably have very good default values. And all these extra fields that are specific to deployments can probably be dropped. So that's what I do when I do dash dash validate equal false. I say, yeah, I know my YAML is not perfect. So please just drop all the extra stuff. Use default values for the missing stuff. And let's go with it. And that works. So now, we might be wondering, okay, what do we have? First, do I have more Docker coins? Yes, I have more Docker coins. This, on the left, the flat thing, was before I added my Daemon set. Now, when I have like 30-something hashes per second, is after adding my Daemon set. I have many more Docker coins. I'm a happy miner. So, I'm not sure if I got the question right, but you mentioned something about the RNG deployment. And yes, now we have, yeah, this is where I explained the error. Okay. Oh yeah, and also give another workaround, which is if we don't want to dash dash validate equal false, we could also like fix the YAML differently. But anyway. Okay. Yeah, now we have both the Daemon set and the deployment, which means that we have 5 pods because we have 4 pods because 1 pod per node and the master doesn't count, plus the pod corresponding to the deployment. So let's see how we're doing on time. Okay. Right. And same thing, that's also another thing that is important to know. How am I going to do that? I'm going to create a new pane and do my kubectl get pods. So now you see I have 5 RNG pods, and you see like they are named slightly differently. Like this one belongs to the deployment, and these ones belong to the Daemon set. So a useful thing to realize is that the names are unique only within a given type, within a given kind. So I can have a Daemon set RNG, I can have a deployment RNG, I can have a replica set RNG, I can have many different things named RNG. Which means that in that specific case, when I changed my YAML, I ended up creating a new object. Here, I dumped the YAML and then I reloaded it that way for a good reason. If you do kubectl edit and then you change the kind, then kubectl will tell you, no. You can't change the kind of an object because that's too complicated. Yes?
By definition, each pod contains many containers, correct? But here we see that for every container there is a separate pod.
Yes, so by definition, a pod can contain multiple containers. And so here we have 1 container per pod each time. So maybe the question is, why can't I put all these in 1 single pod?
Or group them like in compose.
Right.
So I would expect something like that in the pod.
Okay, so let's dig a little bit into that. What if I say, okay, you have 5 RNG containers. Why can't I put all of them in 1 pod? The answer is because 1 pod will be on 1 machine. Here, I want to have my containers on multiple machines, And so the only way for that to happen is to have multiple pods. If I say, oh, let's have one pod with 5 containers, then those 5 containers are going to be on the same machine. So I'm like, I'm back to square one because I wanted to have them spread out on the cluster. Now, what if I think, hey, what if I take the compose file? So I have Redis, RNG, Hasher, WebUI, Worker, and I transform that into one pod with 5 containers, sorry. So with all my 5 containers from my compose file. If I do that, I get a kind of entity that corresponds to my initial app, but unscaled. That's convenient if I want to be able to put them on many different nodes, but if I want to scale services separately, that's not really useful. If you have used ECS, the pods map really well to the concept of tasks. And a task and a task definition is a group of containers that are scheduled together on the same node. Yeah.
So if I understand correctly, the fact that we now have something like 30 hashes per second, although we have the same amount of workers we had earlier, has been achieved by kind of assigning those workers inside the Daemon set, or I couldn't exactly understand what happened that our hashes per second increased after introducing the Daemon set.
Right. Why did the speed increase after adding the Daemon set?
Yeah.
This is because the bottleneck was the RNG service. If we were to look in the RNG service, we would see that in the code there is a sleep 0.1 seconds. Let's not discuss why there is that in the code, but then it's mono-thread, mono-process, mono-request, so it has to handle all the requests one by one. And since there is a 0.1 second sleep in the request, the maximum speed it can do is 10 requests per second. So that's why we were stuck at 10 hashes per second, because you can scale everything you want, like the workers, all you want, but the bottleneck is that RNG service. By adding more instances of the RNG service, now we can go faster.
So this is the first time we're scaling the RNG service, right?
This is the first time that we are scaling something that is behind the load balancer, yeah. Okay. So if we want to check the logs now, we could use kubectl again, like kubectl logs --tail equal 1 and -l run equal RNG. And now I see here like the last line of log for each of these things, and so I see they're all getting traffic. So at this point, yeah, they're all getting traffic. I would like to remove, to get rid of the extraneous pod that is in the deployment. So here, it's time to talk about selectors and labels. So there is a kind of a little bit magic thing that happened here, because I created a daemon set. That daemon set created 4 pods, and automatically these pods started to accept HTTP requests. How did that happen? This
It didn't happen for me, so I'm wondering how did it happen.
Oh, it didn't happen for you, even so you applied the YAML file?
No, I'm not there yet.
Okay.
I won't make it.
Okay, sorry. So the way this works is that in the service definition, if I do like kubectl describe service RNG, it's telling me, okay, we are in the default namespace, blah, 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 and I have a selector. Selector run equal RNG. This means this service is going to send requests to all the pods matching run equal RNG. When I created my daemon set, in the definition of the daemon set, there was that information that said all the pods that will be created by that daemon set will have run equal RNG. So automatically, the pods that I have created already had the right labels to be recognized by the load balancer. Does that make sense? Okay. So how do I remove like that first pod that we had? There are multiple options. So if I delete the pod, the replica set will recreate it immediately. If I delete the replica set, the deployment will recreate it immediately. I mean, the deployment will recreate the replica set, and the replica set will recreate the pod. What if I remove run equal RNG label from the pod? Well, it's exactly as if I were deleting it, because the replica set has a selector as well. The replica set has a selector that says run equal RNG, and it has a count of 1. So the replica set job is to make sure that at all time there is the right number of pods with that selector. And I'm going to show that, like it's kubectl describe replica set RNG. And here, let me type less. I see selector pod template hash equal blah 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 run equal RNG. So there is that run equal RNG, but there is also a pod template hash. This is because I might have multiple replica sets for run equal RNG, and so each of them will have this extra pod template hash that it can find its marbles, like find which pods are its own pods. And if I go a little bit lower, I have a pod template, and this is the template that the replica set will use to create the pods, and it will use those labels as well. Whoops, that was interesting. Okay, so if I remove that label from the pod, my replica set is looking, do I have one pod with my desired labels? So if I remove the label, it's like, oh no, I don't have enough pods, so I'm going to immediately recreate one. So removing the label is exactly like destroying the pod. But that's extremely interesting, because if you have a pod that is in a kind of broken state, you know, like, oh, we identify we have a problem in one pod, the request's like 50% error rate or whatever, and we would like to analyze what's going on. Well, you just have to remove that label, and almost immediately it will stop receiving traffic as well, because the load balancer is like, you don't have the right label, I remove you. And then you can log into the pod and you can try to debug things. So this label mechanism is extremely powerful. Okay.